Welcome back. So this is the review for summative number 2 in the fall of Algebra 2 in 2019. So this first section, this is a repeated section from the last summative as promised. And we decided that the next time we saw this section, we would be way more specific with our variable allocation. So remember that T has to represent something from this story problem here, and it's going to represent the total cost. You guys did a great job with that. I apologize, there's some weird sounds coming out of my computer. I don't know how to turn them off, sorry. And then this next part is where I want you to be careful, because the $2.25 is what you're being charged for each container. So remember, the variable B represents what you don't know about that situation. So we know it costs $2.25, but what we don't know is the number of containers. There we go. And then W is going to represent something that goes along with your 0.75. So if you keep reading, it says 0.75 per ounce of, what are we buying here, granola? So you know it's 75 cents per ounce, but what you don't know, and you can either say the number of ounces of granola, or you can say the weight of the granola in ounces. They both mean the same thing. All right, so first of all, I forgot to start the video with apologies for the weird numbering. I kind of Frankensteined this review together and the numbering's all crazy. We're going to skip around a little bit. Remember last time we saw this question, you guys got to choose between two people's, like two teams, and this time I want you to write the equation yourself, or the expression yourself. So commemorative mug, you have to buy that for $8, and then you're also going to pay $5.50 for each bag of coffee. But you get 2 bags for free. So using the variables they set up, where the total cost, X, is found by buying the mug, $8, and then $5.50, but this is where the catch is. You don't have to pay for 2 bags of coffee. So instead of saying like C for bags of coffee, it's C, but then minus 2, because you get 2 of them for free. So that section is going to be a repeat. Here's another problem that's kind of like that one. So try those out. And remember, I said on the last review, I was really nice and I did all the questions. This is not going to be that way. All right, so moving on to the next section, another repeated section. Oh, before I do that though, you'll notice at the bottom of your review, there's a little note that says there's going to be a bonus question that you can attempt, and it's risk-free. So if you try it and it's not good, it's okay. But you get to attempt the bonus question for some extra credit, some extra points on that section. So if you're doing great, go ahead and try the bonus question. Here's another old section, reviewing, isolating variables. So I'm trying to solve for B. There's just one B in the problem and we have to isolate it. So we're going to start by subtracting Q. I am so sorry if that noise is really irritating. I'll try to figure out how to turn that off for the next video. Alright, so 4B equals 7P minus Q. There is no way to simplify that, so I'm just going to write down 7P minus Q, and then we're going to divide both sides by 4. I don't mind if you do a really big divide by 4 like this. If you separated them into little fractions, so some people write 7P over 4 minus Q over 4. I like either one of those. They're both great. So I'm going to move on to 6A. This is a different kind of question, but the idea is the same. You're still trying to solve for one of the variables. This time it's B. So I want to get rid of the divide by 4 by multiplying by 4, but don't forget you have to do it to both sides. So right now we have 4T equals, these 4's are going to cancel, and you get 5B minus 7. And remember, we're still trying to solve for B. So we're going to add the 7. I'm so sorry. Hopefully no one's watching this video because you all know what you're doing. Alright, so divide by 5 on both sides. And again, I would be totally fine if you just had a really big divide by 5 like this. Or if you separated them, that's fine too. So most of you don't bother separating them because it just seems like more work, you know? I'm with you. I get it. Alright, moving along. We're going to look at number 7. Same review section. This time we're trying to solve for capital B, and there are multiple B's in the problem, and they're not even on the same side. So the first thing we have to do is move anything with a B to one side, which means anything that doesn't have a B in its term to the opposite. So these are gone, and these are gone, but you still have, now to call this what it is, 9B minus 2B is a 7B. And then over here, 9y plus 10, not anything you can simplify. All right, you're almost home free. Divide both sides by 7. and you have your expression for b. 9y plus 10 all over 7. So these next two questions, this one and the next one coming up, are kind of the same idea. You want to group together your target variables, and then you either combine your like terms, or in some cases we can't, so we have to factor out the like term. So let's see what happens here on 8a. Similar idea where you want to bring anything with an a to one side. It doesn't really matter which side you go. I'm going to add the 4a over. Now, since I'm adding 4a to the right, that means I want to move 5 to the left. Ooh, colors are going wonky. Okay, so these are gone and these are gone, and we have 6b minus 5. This is a little weird. These are not like terms, so you have am plus 4a. So now we do that thing, since they can't combine, we have to factor. Factor out the common a, and that leaves me with m plus 4. And over on the left-hand side, there's nothing you can do there, guys. Just write down a 6b minus 5. All right, almost home free. Last step is we're going to divide. So this m plus 4 quantity is going to be divided to the other side. And again, there's nothing to simplify. So these are kind of refreshing in a way where you don't have to do a ton of work. A equals 6b minus 5 over m plus 4. If you decided to collect your like terms to different sides than I did, you're going to have an equivalent but totally okay answer choice. All right, moving along. This is the new stuff. So we're going to ask you to solve the system by graphing. So a little reminder about graphing. When you are graphing in slope-intercept form, that means this guy, right? mx plus b. You start at your y-intercept, and then your m is your slope, so this is the rise over the run. So, sorry about the bings. 5/4 x minus 2. We're going to start at negative 2 on the y-axis, and then your slope is 5/4. So that means you're going to travel up 5 and to the right 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. And then, of course, if you're Mrs. Abruzzo, you're going to kind of draw a line. I should have been more careful, but whatever. This line is going to start at positive 4. See that? But his slope is a negative 1/4. So what I interpret that as being is I move down 1 and then right 4, which is perfect because then I can see where they go. I can see where they intersect. The ordered pair answer is what we're looking for here for the solution. So this ordered pair, this location, is at 4, 3. Make sure that your ordered pairs, remember, are XY ordered pairs. You might want to take a look at number 2 and just remind yourself what it means when you graph the line y equals 4. This is a horizontal line. So you go to the y-axis at 4, and then you draw a line through it. I'm not going to finish that question for you because I would like you to try that one, but that is a common mistake that I see from a lot of kids is they're graphing the line y equals 4 inappropriately. Now, these next few are pains because they're not in y equals form yet, so you have to do a little rearranging. And that's my note to you, rearrange or isolate. So this first one, I would just easily subtract the 3 over. So the 1/3 x doesn't change, but remember we subtracted the 3. This one takes a little bit more work. You're going to subtract the 4x. So right now you have 3y equals negative 4x plus 6. And then you're going to have to come through and divide everything by a 3. And I'm writing on my grid, and that's a bad idea, but whatever. So this equation becomes y equals, this is negative 4/3 x. And then 6 over 3 is a plus 2. So we have new questions to graph, in the right form at least. They're equivalent though. This one's going to start at negative 3, and then your slope is positive 1 over positive 3. So I'm going to travel up 1 and right 3. I'm going to run out of room. I can also move down 1 and left 3. And that's not at all a line. Pretend. Okay, so I missed almost every one of those points. This red one, you're going to start at positive 2 on the y-axis. And then your slope is negative 4 over positive 3. So you could travel down 1, 2, 3, 4, and then right 3. And it was supposed to cross right there. Or intersect is what I should say. And since I graph so terribly, I'm just going to have to kind of fudge this in at 3, comma, -2. So you're always writing your answers for us as x, y ordered pairs. All right, now you are responsible for all 3 methods at 3 separate instances. So on the test, when it says you must solve by this method, you must solve by that method. Substitution is kind of nice because, especially on this one, it's already set up for you. Y equals that, which means anytime I see a y, you replace it with that. So this bottom equation starts off with a -4x minus 4, but instead of y, we're going to replace it with -4x minus 5. All right, clean this up, please. You got to be careful. It's a -4 that you're distributing to here and here. So we end up with -4x. This is a plus 16x. This is a plus 20. And it equals 20. Now don't panic. A lot of kids panic here. Combining my like terms, I get a 12x, and then right here you're going to subtract 20 from both sides. So you get equals 0. 0 is a number. You can divide 0 by 12 and you still get 0. So this isn't one of those weird all solutions, no solutions thing. This is just your x value is 0. So now you got to go back and find your y. And what I do like about substitution is this formula right here, the thing we boxed in, that's a recipe for y. So if you're trying to find y, you just plug in 0 for x. So -4 times 0 minus 5 should give you a -5. So there's your y value. Substitution is awesome if it's already set up to substitute, but sometimes it's not. So you got to come through the questions and realize, okay, who would I like to isolate so that way I could substitute? And I look for the variable that has the smallest coefficient, preferably a positive one as well. So I'm eyeballing this x right here. If I could solve for this x, I could rearrange, that would be awesome. I'm going to subtract the 4y over. I'm going to write it as -9 minus 4y. That is what I'm going to substitute in for that x. Alright, so negative. Instead of x, we're going to write down that red thing. Oh my gosh, the noise is driving me crazy, so I can't imagine what it's doing to you people. Okay, I'm so sorry. What do we have here? A positive 9, and then a positive 4y. Uh-oh, something weird's going to happen. So this is a case of weird solutions. The 4y and the -4y cancel, and right now my statement says 9 equals 9. Well, that's true. It's just not a solution, and that's because you have infinitely many solutions. Alright, I tried to mess with the audio a little bit, but I don't know if it did anything. I don't think so. So sorry, still gonna hear those weird pings. My bad. Alright guys, real quick, let's talk about elimination. Remember, elimination is awesome if things are already set up to eliminate. So like here, I would really love to eliminate the y's. I notice they already have opposite signs. And the only way that'll work is if I make this 1y a 10y. So we can do that by multiplying that bottom equation by a 10. So the top equation hasn't changed. But this bottom equation becomes, I feel like I did something very wrong here, 100x plus 10y equals -30. Oh, this isn't bad. But something weird does happen. Kids freak out here, like I said. You get 102x, which freaked me out. These are canceling each other, but it equals 0. And anytime you divide 0 by anything, you're going to get 0. So right here, you found out that x equals 0, which is totally part of your ordered pair. I'll write that up here. And now we got to go back to our favorite equation and figure out why. I'm going to go back to the top equation. So 2 times 0 minus 10y equals 30. Of course, 2 times 0 is 0, so we have -10y equals 30. Dividing both sides by -10. And we get y equals -3. So writing your answer as an ordered pair, always important to your math teachers. Make sure you're writing them as x, y ordered pairs. Sometimes you have an elimination question where there's not a real obvious common multiple, and a trick that will always work is if you multiply the numbers by the other number. So like you pick which variable has opposite signs. So for number 11 here, they both have opposite signs. Let's say I wanted to knock out the y's. That means I could multiply this y by the 4 and this y by the 7. So if I did that, I'd create brand new systems. If I can actually multiply today, that would be good. Oh boy, 56 plus, minus 28. Y equals 140. Oh, I don't have a calculator. Let me think. That's 32. X equals, oh, I feel like I screwed something up again. 160. And then I think that is 5, right? So the ordered pair, I know the x value is 5. Now I go to my favorite equation, which happens to be the bottom one here, and I plug in x equals 5. So 8 times 5 instead of 8 times x minus 4y equals 20. I don't know why I keep writing this so close to everything else. I have plenty of room. Let me just move this around. There we go. So 40 minus 4y equals 20. Subtracting 40 from both sides, you get negative 4y equals negative 20. Oh, this is cute. Y is 5 as well. So you don't have to do like crazy work here, guys. It's really just basic algebra work, but they're so easy to mess up on. So go slow. Much slower than I'm going right now. All right, so here, remember, all you need to do, you don't have to solve them. You just set up your variables and set up your system. So you really should assign your variables first. And then right here, the question is what your variables are. It's the selling price of each type of plant. So you can use whatever variables you want, but if you're old school, you're just using X and Y. And the two types of plants are rose bushes and ivy plants. So remember, it's the selling price is what we don't know. So you can say it's the cost of one rose bush. And then again, it's the cost of one ivy plant. Ooh. Make sure you're very specifically and accurately telling me what those variables represent. So the first person, Mickey, bought 10 rose bushes and 1 ivy plant for $33. So 10 rose bushes and 1 ivy plant for $33. And then Donald bought 13 rose bushes and 9 ivies for $66. It does not matter what variables you chose to assign for these two unknown things. What does matter is that you're using them properly and you're explaining what they are very specifically. So be careful on that section. It looks really easy, but it's also very easy to mess up. And then here, oh, this is the new stuff, right? We're solving inequalities. It's not really new to you guys. You've done this before, but remember, there's some rules about solving inequalities. You want to treat it like an equation, except I'm going to go old school on you, and I'm going to tell you have to bring your variables to the left side. So I'm not going to mess with the left side yet. I'm going to distribute the negative 6 on the right side, and we're not going to mess with the inequality sign yet. So you have a negative 48r and then a plus 12. Now, because of the nature of the questions, they have to read with the variable on the left. So you are going to add the 48r over here. And while we're at it, I'm going to add the 39 to the right side. And I wrote really sloppy. I'm so sorry. So right now you have 51r is less than or equal to, oh, look at that, 51. So dividing both sides by 51. You don't have to flip your sign in this case because your coefficient that you're dividing by is not negative. And you're going to get, oh my gosh, where is my extent page? You're going to get r is less than or equal to 1. But this is not the end of the problem. Because now what I need you to do is I need you to graph it. That's called the inequality solution. Now I need you to graph it. So, like here's 0, here's 1, I got that. And I'm going less than or equal to 1, which means I'm shading in everything to the left of it, and then I'm using an inclusive bracket on 1, because the equal to bar is why you're using the bracket. And then finally, a domain interval. So your solutions, remember who lives down here is negative infinity? Your solutions start at negative infinity, and they end at 1 with a bracket. So all 3 of these are solutions that you're going to need to do for your test. You have to show me all 3 of them. Make sure your domain goes from left to right. Make sure that your negative infinity, or if you eventually have a positive infinity, make sure there's a parenthesis on it. You cannot have a bracket on infinity. And then my favorite questions, they're called sandwich questions, unofficially by us. It's 2 questions in 1. So you're trying to solve for n. We know we have to move the 10 first. and you're just going to simultaneously solve them all at the same time. So what you have right now is -5 is less than -5n, which is less than 10. So in this case, you're going to divide by -5 here on the last step, but because you're dividing by a negative coefficient, now all the signs are going to reverse. So this simplifies to a 1, but now it's going to be a greater than n, which is greater than -2. Now if it bothers you that they're reading in the wrong direction, you could rotate the whole inequality around and say -2 is less than n, which is less than 1. Either way, I like both of those inequalities, but they are right sandwich. That's what we call them, sandwich. So on your number line, it's all the solutions between -2 and 1. Just make sure they go in the right numerical order. -2 is smaller. And sandwich means it's everything between them. It's including the spaces between them. And because there's no equal to bars, you're going to use parentheses on each of them. So your interval for your solution goes from -2 to 1. Now, man, that sure does look like an ordered pair, doesn't it? But because of the nature of the question, we can understand that you're talking about an interval. That's what that looks like. Very cool. All right, so that is it's a quick rundown. I apologize of everything on your summative number 2. 2 old things are showing up. Hopefully you're able to do those bonus questions that get extra credit. And then there's a few new sections here that I'm hoping for some good scores, especially on the systems. I feel like, a lot of these things are old news to our algebra students, and we should be able to do a little better on them now that we're in Algebra 2. All right, good luck, everybody.